Hello all, I'm Dr. Maya Durna. I'm planning to discuss in this video is quantum numbers. Quantum numbers are the solutions for the Schrödinger equation. So there are mainly, we are discussing the 4 quantum numbers. Quantum numbers you can think in an easy way is how electrons are arranged around the nucleus. For any atom to describe the electrons arranged around the nucleus, we can describe that electron arrangement in these 4 quantum numbers. So let's see what are these quantum numbers. Mainly, I told you there are 4 quantum numbers. Very first quantum number we are learning is principal quantum number. Principal quantum number denoted by letter n lowercase. Principal quantum number describe the energy of an orbital. It describes energy of an orbital. Always principal quantum number get the numbers of 1 or above. It should be an integer, but it should be always it's above 1 or equal to 1. Sorry, 1 or above 1, but it should be a whole numbers, integers. So n equals 1 or greater than 1. So it can be 1, 2, 3, 4, like that. Whole numbers can be the value for quantum numbers, principal quantum number. Basically, principal quantum number is, so this is the nucleus. Around the nucleus, you have first principal shell, second principal shell, third principal shell. So n equals 1, n equals 2, n equals 3. Okay. So this is the principal quantum number. And we are moving to our next quantum number, which is angular momentum quantum number. So our next quantum number is L. L is angular momentum quantum number. Angular momentum quantum number defines the shape of the orbital. N. So L can be 0 to n minus 1. That means if n, so I told you n can be, so it's here, n can be 1, n can be 2, n can be 3, right? So L can be, for n equals 1, L is, equation is, L is 0 to n minus 1. So the 0 to n minus 1, 0, L minus 1, so it's 0. So that means at the first level, there is only one orbital closest to the shell, which is 1. So you go to n equals 2 level, you apply this relationship. So L is 0 to 1. This one you have 0, 1, 2. So these are the L values for angular momentum quantum number. So I have another important thing I want to show you here. Value of L is 0. If value of L is 0, where we can find the value of 0 here? Value of L is 0. That means you have only s orbital. So s is a new term we are learning. There are mainly 4 orbitals we are learning: s orbital, p orbital, d orbital, and f orbital. Orbitals means where the electrons reside around the nucleus of an atom. At the very first chapter, we describe around the nucleus, electrons are residing around the nucleus. And how, what around which shape? So each orbital has a shape. So that means the basically electron is very small. very small, so it's showing like a wave nature. It has more like wave properties, so electron are always rotating, moving around the nucleus. If you say electron is in an s orbital, that means s orbital is spherical. Electrons are rotating around the spherical shape around the nucleus. So now we'll take, okay, n equals 1, principal quantum number 1, L equals 0, L equals 0 means you have s orbital. N equals 2, L equals 0 to 1. That means you have 0 and 1. 0 means you have s orbital, 1 is p orbital. N equals 2, 3, you have 0, 1, 2, s orbital, p orbital 2, L equals 2, d orbital. So depending on the L equals 0, s. L equals 1, p, L equals 2, d, L equals 3, f, s, p, d, f. These are the types of orbitals. So this is the angular momentum quantum number L. And then I am moving to our next level, which is magnetic quantum number. Magnetic ML. Magnetic quantum number describe the three-dimensional orientation of orbital. Magnetic quantum number describes 3D orientation of an orbital. What is that 3D orientation? So what is the relationship of L and ML? You know what is the relationship of N and L? N is in always 1 or 2, 3 goes like that. L is 0 to N minus 1. So ML is negative L to positive L. ML is negative L to positive L. So let's take this diagram again. N, L, M, L. N, L, M, L. N equals 1, L equals 1. ML is 0. Sorry, N equals 1, L equals 0, which is s orbital. S orbital. S orbital means there is only one s orbital. N equals 2, L is 0 and 1. 0 means s orbital. 1 means p orbital. So ML is negative L to positive L. 0, there is no negative to positive. But if you think about p orbital, it's going to be negative 1 to positive 1. It's going to be negative 1 to positive 1. So you go to N equals third level, 0, 1, 2. 0 is s orbital, p orbital, d orbital. In this one, negative 1, 0, positive 1, negative 2. D is L equals 2, negative 1, 0, 1, 2. Right? So this is how the quantum numbers work. So there are mainly four quantum numbers. Four quantum numbers are principal quantum number, angular momentum quantum number, magnetic quantum number. Principal quantum number, which is n, describe the energy. Higher the n, higher the energy. It's always integers, 1 or above 1. And then after that it's L. L is angular momentum quantum number. Angular momentum quantum number, it can be it describes the shape of the orbital. The relationship is L equals 0 to n minus 1, and then L values can be if L equals 0, that is s orbital, L equals 1, p orbital, L equals 2, it's d orbital. For any atom, you can write the electron configuration like this. Okay, and if you think about ml, negative L to positive L, that means for s orbital, it's only one orientation, but for p orbital, negative 1, 0, positive 1. That means you have 3 orbitals, which is 3p orbitals, 5d orbitals. So that is the relationship. So if you look at this one, this diagram, or for any atom, example hydrogen, right? Let's take hydrogen as an example. Hydrogen, you have only one electron, right? Hydrogen, you have only one electron. Hydrogen, one electron. How do you classify these quantum numbers to hydrogen? Hydrogen, what is the principal quantum number? Principal quantum number means hydrogen has only one electron, n equals 1. What is the hydrogen's magnetic quantum number? N equals 1. Angular momentum quantum number L is 0. ml, magnetic quantum number 0. Hydrogen 1 electron, L0 means it's in s orbital. Always this 1s. Let's take oxygen. Oxygen has how many electrons? Oxygen has 8 electrons. 8 electrons distributing, and also oxygen in the group 2. N for oxygen is 2. So you may wonder how I take N is 2. N has 8 electrons. So in the periodic table, N is in group 2. Any element in group 2 has 2 principal shells. So example, if I draw oxygen, and this is the first shell, closest shell, which is S shell, fill only up to 2 electrons. The remaining will go to the outer shell. Outer shell, which is the next shell, which is N equals 2. So this is N equals 1. N equals 2 can go up to 8 electrons. So you can go E, 2, 3, 4, 5, 6. So now it's 6 electrons filled. So 2 principal shells, N equals 2, L equals 0, 1. 0 means you have only one s orbital, 3 p orbitals. 3p orbitals. 3p orbitals are plus L, 0 plus 1, 0, negative 1. So this is how you arrange the quantum numbers. Example, if you take quantum number 4, fourth quantum number, possible values of L, you have 0, 1, 2, 3, you have 3 possible values. That means you have L equals 0, s orbital, L equals 1p, L equals 2d, L equals 3f orbital. So like that you can write the shells. Always N you call principal shell. N is a principal shell, L are the subshells. Number of L's are we call subshells. Hope this helped you to understand the chapter 6. Thank you.